Good evening, everybody. Welcome to Chem 170 with your host, me, Dr. White. Hi, everybody. Tonight, I'll be doing the review for test number 2. Yep, test number 2. And in case you forgot, this Thursday at 8 a.m. or earlier, I will send out a pass email with the password for the password protected PDF file for test number 2. You'll download test number 2 from the assignment area, open it up with the password. You'll have until Friday, the 7th of March, 8 p.m. to finish test 2 and upload your answers for test 2 to the assignment area D2L. Did I say Blackboard? Wrong school. Oops. But anyways, I'm getting all choked up over that. Anyways, it should take you about 45 minutes if we were face to face, but we're not. So take as long as you need. Make sure you upload your answers by Friday deadline. Test number 2 is an announcement, which went out on February 26th. Has 9 pages, 10 problems. Some of the problems are multiple part. I have never and will never give a multiple choice question on a test or final in Chem 170. Now, test 2 covers the following functional groups: alcohols, thiols, ethers, ethylene oxide, aldehydes, and ketones. And these are, if you're looking at the modules 5 through 9. Now, the point breakdown for test number 2, general knowledge, 11 points, nomenclature, 34, reactions, 60, and it adds up to 105. So there's five bonus points. This is not an open note or open friend or use the internet. You should not be doing that. It's cheating. I have things in my test that show if a student is cheated by doing one of those, and I will do what's in my syllabus. Please do not cheat. And right now I'm doing this review. All right, one thing I do want to point out, if you go to content, let me go to student view. If you click on content, then scroll down to where it says lectures, then scroll down. And for this, see at the very bottom, there's a button that says load more. You have to do that. Click on that. And as you scroll down, you'll see test 2 review, both as a Word document and a PDF file. And this is the file I'll be going through tonight's review. Again, you probably will have to click on load more, like I just did, to see these files. All right. And let me remind you, for test 2, your friend will be how many bonds to carbon? 4. Do you break carbon-carbon single bonds? No. Those will be your 2 friends when you take test 2 and 3, 4 in the final. All right, let's get to work. And by the way, the best way to get prepared for test 2, hopefully by now, you've watched my videos and done the practice problems. The practice problems will help you do well on test 2 plus the review here. This review, I believe, contains all the reactions you need to know for test 2. All right, let's get started. First, let's talk about an alcohol. What is an alcohol? A hydroxyl group, OH, on a carbon. And any carbons, we use the letter R. That's an alcohol. Now, how do you name them? Name the longest chain or ring as an alkane or cycloalkane. If it's an alcohol, you drop the E, add OL. If it's acyclic, you need a number. What carbon is the hydroxyl group on? And that always has priority, meaning the lowest number. Now, if it's on a ring and there are no other functional groups, which is what will be on my test, oops, for cyclic, you need no number because the carbon with the hydroxyl group is always number one. Now, a special alcohol, you should know that both the IUPAC and the common name are the same, is phenol. And that's a benzene ring with a hydroxyl group on it. Now, I talked about common names. And common names name the R group, the alkyl group is that is the hydroxyl group attached to, and add the word alcohol. Now, by the way, don't forget an important product with alcohol in it is rubbing alcohol. And that has 70 to 90% isopropyl alcohol, and the remainder is water. Another important alcohol product is hard spirits, like what used to be my favorite, vodka. That has ethanol and alcohol. Also Canadian Club and Harvey Bristol Cream, to name a few. Amaretto. Well, never mind. All right, how do you make a alcohol? Well, this is the only reaction that will be on two separate tests, other than the final, which is cumulative, but on the test. And that's if you take a double bond, add acid, H plus means acid, and water. Think of water as H and OH. You break the pi bond, one carbon gets the hydrogen, the other gets the hydroxyl group, and it follows Markovnikov's rule. The carbon with the most hydrogens gets the hydrogen, the other carbon in a double bond gets the hydroxyl group. All right, now reactions of alcohols. If you take an alcohol that has an adjacent carbon with a hydrogen, adjacent means connected to that carbon with the OH group, and heat, that's what this little triangle means, and sulfuric acid, H2SO4, you lose the water and form a double bond. And this follows Zasev's rule. And if we look at the alcohol problem set, let's look at F. Now, F, we have this molecule. And by the way, in test 2, when you look at a molecule, look for what's different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond should get your attention like this. Ooh, OH group on a carbon, alcohol. Sulfuric acid, H2SO4. Heat, and sometimes I put the 180, sometimes I don't. Dr. White can be lazy, organic chemist. And this is a dehydration where you'll lose right here, sulfuric acid and heat, lose water, and you get a double bond that follows Zasev's rule. Well, here's the carbon with the hydroxyl group. Adjacent carbon with hydrogens is this one, I'll call that A. And this one has hydrogens, I'll call that B. Creative, aren't I? Nah. Anyways, if I lose the hydrogen from A and the hydroxyl group between these two carbons, I'll form a double bond. Do you break carbon-carbon single bonds? No. So I start out with 1, 2, 3, 4 across plus the methyl 5. 1, 2, 3, 4 across plus the methyl. Part of the 3 is in the circle there of the CH3. And here's the double bond. Now, if I lose the OH group and a hydrogen from B, I still get my 4 carbons in methyl. But between these 2 carbons, B and the carbon with the hydroxyl group, I'll form a double bond. Now, Zayseth's rule is you get the product that has the most carbon atoms directly bonded to the carbons of the double bond. Well, here I have circled this one, and that's 2. Isn't the math hard in my class? Not. All right, now here, it's double bond. We have 1, 2, 3 carbon atoms directly bonded. You don't count this methyl up here. So which is the greater number, 2 or 3? Time's up, 3, and that's why B is the answer, and that's how you do Zayseth's rule. And if you go to the very end of this problem set, I put in another example for you to look at or to work on your own first. All right, let's continue. Now, if you take an alcohol and react it with HX, where X is chlorine, bromine, or iodine, you replace the OH group, the hydroxyl group, on the carbon with the OH group with a halogen. Now, this is not good if you have a double bond. So someone came up with, if you take an alcohol, react it with thionyl chloride, you will replace the hydroxyl group on the carbon with the hydroxyl group with now just a chlorine. And I've done both of these reactions. And SOCl2 is interesting stuff to work with, to say the least. All right. Now, remember, placement is important. In these 2 reactions, what you're putting on new goes on the carbon where the hydroxyl group. The rest of the R group comes along for the ride because you don't break carbon-carbon single bonds. No. All right, now, if you have a primary alcohol, 1 R group on the carbon with the hydroxyl group and oxidize it. O in brackets means oxidize. Instead of having you learn the different oxidizing agents like sodium dichromate, potassium permanganate, I'm just using the general form O in a bracket. And you lose water, and between the carbon and oxygen, you form a carbon-oxygen double bond. And as you'll learn later, this is an aldehyde. You take a secondary alcohol, 2 R groups, they can be the same or different, that's why it's R and R prime, and oxidize it. You'll do the same thing, lose the hydrogens here, and form a carbon-oxygen double bond. And now we have a ketone. Now, tertiary alcohols cannot be oxidized. However, I will never put on my test where I ask, give the product or products, and the answer is no reaction. I will never do that. I don't think that's right. If I ask you what's the product, there should be something made. So that reaction of a tertiary alcohol oxidized, I'll never put on a test or final. All right, next I talked about thiols. That's carbons, 1 of the carbons in the R group has a sulfur and a hydrogen. This is called a thiol, the old name mercaptan. And the 2 things you should know. 1, thiols stink. Oh, think about skunk odor, which is a thiol. Stink. The other important thing you should know is they put a stinky thiol in natural gas. That's the gas you cook with, or if you have a gas oven and stove, like Dr. White does. And if there's a leak, you can smell it because methane, natural gas, has no odor, but the thiol they put in which is real stinky. They only put 4 pounds per billion pounds of gas, 4 pounds of thiol, about 4 parts per billion, and that makes it stink enough, you can tell. All right, next I talked about ethers. R group, oxygen, R prime. Now, I didn't go through the IUPAC name. Nobody ever uses it for smaller common ethers, but the common name is name each R group as the alkyl group it is and add the word ether at the end. Now, there's only one reaction I asked you to show, and that's the Williamson ether synthesis. An alkoxide, RO minus Na plus an alkyl halide, R prime X, where X can be chlorine, bromine, or iodine. This attacks the carbon with the halogen, and the oxygen bonds to the carbon in R prime with the halogen. And from this, you also get salt, NaX. Now, one of your colleagues asked, if I were to put this in a synthesis, do you have to show the O minus Na plus? Because you just write RONA. And the answer is yes, either way. Dr. White likes to show charges. It's cool. Dr. White tries to be a cool dude most of the time, but you don't have to do it. All right, next I talked about epoxides. And I really only talked about one epoxide, which you don't have to know the name, but should be familiar with the structure, and that's ethylene oxide. And I only talked about 2 reactions with ethylene oxide. Alcohol with 1 molecular mole of ethylene oxide gives this ether alcohol. And this is important, what we call surfactant. Another type of surfactant is when you react that same 1 molecule of alcohol with now N molecules, or if you remember your stoichiometry, N moles of ethylene oxide, and you get this poly, meaning many ether alcohol, where in the bracket is OCH2CH2, and then closed and subscript N comes from the coefficient here. The hydroxyl group is on the outside, not inside the bracket. You put it inside the bracket, I will mark it wrong. Please don't. And there are problems here. Don't forget, on test 2, under reactions, I think I have 3 or 4 synthesis problems. A little different than test 1, a lot more reactions, because that's what I'm spending a lot more time on. And this is a very important surfactants too. I worked for a company, 2 companies that made these. All right, next, something near and dear to Dr. White's heart, and that's aldehydes and ketones. My first patent and my last patent, US patent, dealt with aldehydes and ketones and what you could do with them to make a product line that made a lot of money and helped people. All right, aldehyde, carbon, double bond to oxygen with an R group and H. How do you name it? Find the longest chain with the carbon double bond to oxygen. Name it as an alkane. Drop the E, add Al. No number, because the carbon double bond to oxygen is number 1. Let me jump ahead for a second. That carbon is called the carbonyl group. To me personally, I know of nothing more important than in all of organic chemistry than the carbonyl group. If you were to ask what kind of chemist are you, and I was totally honest with you, the only answer I could give is I'm a carbonyl synthetic organic chemist. Most of my work has dealt with my knowledge of the carbonyl group. Dr. White loves the carbonyl group. And you should know how to describe the carbonyl group with words. Carbon or carbon atom, double bond to oxygen or oxygen atom. And you should know how to draw it right here. And this carbon double bond to oxygen is called the carbonyl carbon. which I'll be using in I did in my lectures. And when there's no number, because the carbonyl carbon, this carbon right here is number 1. Now, you can't have an aldehyde in a ring. You can't. But when you have 2 R groups that can be the same or different R and R prime on the carbonyl carbon, that's a ketone. Dr. White loves ketones too. How do you name it? Find the longest chain or ring and name it as an alkane or cycloalkane. Drop the E, add ONE. If it's acyclic, not in a ring, you need a number. Which carbon is the carbonyl carbon? That always gets the lowest number, priority, and it's always closest to the ends of the chain. Now, if it's cyclic, you don't need a number because the carbonyl carbons rock, and that's always number 1. Now, 2 common names that nobody ever uses the IUPAC name for, and you should know. The simplest aldehyde, turns out R can be a hydrogen, is called formaldehyde. Nobody calls this by the IUPAC name methanal. The simplest ketone is this one. 3 carbons, acetone, and R and R prime are methyl. Nobody ever calls this 2-propanone. Don't forget, acetone can be used as nail polish remover. And if you go to a big box store like that French store, Target, or Walmart, you'll see most of the bottles of nail polish remover, if you pick it up and look at the bottom, back, and the ingredients will be acetone. Again, and it's in red, so you know it's important. Remember, carbonyl group. Carbon, double bond to oxygen. You should know how to describe it with words and draw a picture of it, as I have here. Carbonyl group, carbon atom, double bond to an oxygen atom. All right, now I've already gone through these 2. If you've, in the last chapter, take a primary alcohol and oxidize it. That's what the O in the brackets means. You form an aldehyde. You take a secondary alcohol and oxidize it. You form a ketone. Now, there's a special reaction. This is one of those reactions where you make a carbon-carbon single bond. You start with a benzene ring, then R carbonyl and chlorine to the carbonyl carbon. It's called an acid chloride. And you have aluminum trichloride catalyst. This is Friedel-Crafts acylation. And you make an aromatic ketone. And one use of aromatic ketones is as sunscreen. It absorbs the harmful UV light. All right, let's talk about reactions of ketones and aldehydes. A lot of them are the same. If you react a certain reaction with either an aldehyde or a ketone, it's the same type of reaction. And to show that, here I have a carbonyl, R double prime, and R prime. If R prime is hydrogen, that's an aldehyde. If R prime is carbons, this is a ketone. Now, if you react it with an alcohol with acid catalyst, H+, keep your eye on the carbonyl carbon. That's where the fun is. You get this. It opens it up to OH group and OR, where the R group here comes from the alcohol. Now, if you use 2 alcohols and acid, keep your eye on the carbonyl carbon, what's attached to it, and there should be a bracket here. Hold on. Sorry about that. Now, you know, I was telling you the first day of class, I don't walk on water unless it's frozen. Even then, I stay off it. In other words, I can make mistakes. But here, if you have an aldehyde or ketone, 2 molecules or moles of alcohol, acid catalyst, you form this, the acetal or ketal, where both OR groups are on the carbon that was the carbonyl group. Now, both of these reactions we'll talk about later because Mother Nature uses these. By the way, Mother Nature is the greatest of all organic chemists to make carbohydrates, like the good stuff in life, potatoes, rice, French fries, the good part of one of the good parts of a pizza. All right, now there's a special case I talked about that my advisor, is PhD advisor, Dr. Stork, discovered or created, and that's if you take ethylene glycol, that's this molecule here with the two hydrox groups, and acid with an aldehyde or ketone, you make this. This is called a protecting group. Don't forget the carbon-carbon single bond between the two CH groups. Now, these two reactions I just showed you, you can undo. How do you do that? Well, if I take a acetal or hemiacetal, react it in acid and water. Remember, in your stomach, there's hydrochloric acid, H plus, and water. You break down and get back the aldehyde or ketone you would have used to make that hemiacetal or hemiketal plus the alcohol. And this is one of the steps Mother Nature uses to allow you to break down carbohydrates. The other reaction is if you take a acetal or ketal, and these are both similar. These are the only two cases I know of in all of organic chemistry where you have two single bonded oxygens to the same carbon, and they give the same products. Acid and water breaks it down. You get back the aldehyde or ketone plus the alcohol you would have used to make that. Remember, what's attached to the carbon with the two oxygens, same here and here, are still attached there because you don't break carbon-carbon single bonds. Now, as I told in the video years ago, I had these twin sisters in this one organic chemistry class that I taught this in. And if I didn't show the two, they'd say, what happened to the other R group? And they get all upset. And you don't want twin sisters upset at you. No, no, no. So that's why you'll see the little two there. The brackets means you don't have to put it there. Now, Dr. Roy's going to have some fun. If you take an alkyl halide and react it with magnesium, you form the Grignard reaction, MgX. If you put XMG, I'll mark it wrong. And that's on the same carbon that the halogen was on. The halogen can be on the carbon with the halogen can be chlorine, bromine, or iodine. Now, what do you do with the Grignard reagent? By the way, one of my great heroes in organic chemistry is the great French chemist, Victor Grignard, Dr. Grignard. Now, if you take an aldehyde or ketone, and the first step you react it with a Grignard, R triple prime MgX, second step, acid and water, you do something very special. You make a carbon-carbon single bond. And this attacks that, by the way, organic chemists are violent. This attacks that and forms this bond and opens it up to an alcohol. Let's do one. I want to have some fun. So the question is, give the organic chemist, give the organic product or products. By the way, when I say the word give, that means draw the structure. Don't forget that. You see, give the structure, that means draw the structure. All right, let's look at what we have here. What's different here? Ooh, carbonyl. Carbon double on the oxygen. Carbons here are prime. Carbons here are double prime. This could have been a hydrogen, but this is a ketone. Then the first step, magnesium chloride. This is a Grignard. Oops. Where X can be, in our case it is, chlorine, bromine, or iodine. Second step, acid and water. And this attacks that. Second step protonates what you make to make this alcohol. And you've made a carbon-carbon single bond right here. And what's attached to it? The carbonyl carbon is now attached to carbon with the OH group. So here's our prime. Here's our double prime. Here's our triple prime. Here's my carbonyl carbon. I'll draw that first. What's attached to that? Our prime. What's attached here? Our double prime. Remember, you don't break carbon-carbon single bonds. My general reaction says my Grignard will be attached to that, and this is R3, and it will have an alcohol. And that's a Grignard. Dr. White loves this reaction. And actually, I used it a number of times in my research for my PhD thesis. Was that fun or what? Yes, it was fun. All right, now, carbonyl is a double bond, and that's one pi bond and one sigma bond. And like you learned for double carbon-carbon double bonds, if you add hydrogen gas and a catalyst, where the catalyst can be nickel, platinum, or palladium, you break the pi bond, and each, in this case, atom of the double bond gets a hydrogen, and this is a neat way of making an alcohol from a ketone or aldehyde. Now, if you had a double bond in this molecule, which we won't in this class, but in real life you could, this hydrogen catalyst would destroy that, hydrogenate that. And a great organic chemist said, I believe Purdue, Dr. H.C. Brown, back in the late 1940s, came up with a new reagent, and he won the Nobel Prize for that, lithium aluminum hydride, LiAlH4. Take an aldehyde or ketone and react it with first step lithium aluminum hydride, second step acid, H plus, and water. You get the same thing. You break the pi bond between the oxygen and carbon, and each atom gets a hydrogen. However, this reagent will not react with carbon-carbon double bonds, which makes it very useful, and I've used it. All right, next, the aldol condensation. The carbon bonded to the carbonyl carbon is called the alpha carbon, and the hydrogens on there are acidic. I did my research on, this is called when you react it with a base, NaOH is a base, you form an enolate anion, which will attack the other carbonyl carbon present, in this case, the other aldehyde, and form a carbon-carbon single bond, opening up the second carbonyl to an alcohol. And this is called an aldol condensation. It's a very useful one. And that's it. Remember, Thursday, I'll send out the password 8 a.m. or earlier. If I get up earlier, I'll send it out earlier. And don't forget, continue to hand in your labs. Labs are important points for your final grade. If you don't hand them in, it'll hurt your final grade. Really. And finally, there's no such thing as a dumb question in my class or my world. If you need help, come to my office hours on Monday and Wednesdays on Zoom from nights from 6:30 p.m. to 7:30 p.m. If you can't make it then because you might be working, reach out to me by email and I'll see if we can find a mutual time when we can meet on Zoom in a private meeting where I can help you. And with that, I'm done. Good luck. Well, hopefully you won't need luck. You've done your practice problems for test 2 this Thursday. Remember, I'll say it's in Yiddish. It means go in hell, gehen gesund, and then you know what's coming next. If you watch the videos, I stole this from Granny from the Beverly Hillbillies. Bye now. Bye. Bye now. Bye.